Assalamualaikum and very good afternoon. So we continue for new topic, chapter 3. So for the purposes, we already know what is the process of the water supply. So what is the standard behind of the water supply? Need you comply in the raw water or after treatment. Okay, so when we already use the water, so of course we will be produce the waste. Okay, if we use the water, so we already have the wastewater. So what we should do, so in the chapter 1, you already know what is the self purification. So certain of the water bodies, they have their own own capacity to purification of the water. So in the certain area, such as in urban area, developed area, so the amount, the volume of the wastewater is the huge. Okay, so this is quite difficult to discharge directly the wastewater into the our body, stream or river. So that's why this is the important to construct, or we need to have the treatment for our wastewater before we release to the water bodies. To this is the importance of the wastewater, to make sure our stream or our water body still have a good condition or not polluted by our wastewater. Okay, this is important for the wastewater treatment. Okay, so in this topic, they have the 13 subtopic. Type of the wastewater until the sludge or byproduct of the wastewater treatment plant. Okay, what is the wastewater? Okay, the basic words of the water, the waste, okay, come from the produced by your activities, okay, that produce the wastewater. Okay, in the definition, any water that have the adversely affected in the quality by anthropogenic influences. Okay, influence. So anthropogenic ni human lah, human activities lah, any human activities. Okay. So here they have the two. Usually they have the many type of the wastewater lah, but the major wastewater is the domestic and industrial. So domestic, that mean come from the resident area, commercial outlets, okay, institutional like UTHM and so on, recreational facility, it contains decomposable organic matters and pathogenic agents. So this we call as the domestic. So what is the industrial? So you should know lah. You can differentiate. You can differentiate between the domestic and industrial. You should know lah what is the difference between the domestic and industrial. So domestic from commonly from the residential, commercial, institution, so human activities. Okay, so for the human activities that use the water, produce the wastewater, okay, that's we call as domestic. So industrial process generate wide variety of the wastewater pollutant. It contains toxic agents ranging from the metal salt to the complex synthetic organic chemical, in which specific toxic and hazardous compound may exist. Okay, so industrial process. So kalau for the industrial wastewater, that means from the industrial process. Okay, kalau domestic, if for the domestic, commonly from the human activities. Okay, so wastewater contaminants. So if the wastewater content of the suspended solid, that we cause sludge deposit and anaerobic condition in the environment. So for the biodegradable organic, cause anaerobic condition in the environment, that's an impact. If the content of the pathogens transmit disease, okay, let's say diarrhea, so this come from the pathogens. Heavy metal, okay, this heavy metal usually have the big impact. So they will be toxic to biota and human. And refractory organic, similar with the heavy metal, the impact will be give to toxicity to the biota and humans. Okay, dissolved solid interface with the reuse. Okay, nutrient cause eutrophication. Okay, so in the Malaysia, where sewage goes? Okay, this is the typical flow of the sewage. So from the premise, flow to the underground sewage water pipeline into the public. Okay, sewer pipeline into the public sewerage treatment plant for the treatment before the effluent release back into the waterways or stream lah. Okay, so this waterway to stream. So the our domestic activities, house, using industry and so on, come to the STP. Okay, so networking pump station depend of the location of STP. If the STP gravity the location, so this one activity and then this one STP, so not required lah to install for the pumping station. But if the STP higher than the location of the STP higher than the wastewater produce sources, so they need to install the pump station. Okay, so after treatment they have the byproducts. Okay, byproduct is the sludge, so they need to treat before we discharge into the dump area or other area lah. Okay, and lastly the effluent can come out and release or discharge to our water bodies. Okay, this is the sewage treatment plant process at the STP. So have the primary screen. Okay, so what is the purpose of the primary screen? Remove rocks, roots, wax and other coarse materials. Okay, so pump station to pumping. Okay, so this one I just explained previously, from the lowering area to can flow to the STP. Okay, and PS required if the STP elevation or level is the higher than the source of the wastewater. Okay, so NP sewage treatment plant provide consist inlet flow, and PS have the good ventilation and odor control system to contain exhaust and treat odors sewage gas. This minimum odor reach neighbor premise. Okay, so this in the pump station lah. So secondary screen, grid removal and grease trap. Okay, balancing tank ataupun equalization. This one balancing tank ataupun equalization tanks. Biological treatment. Okay, ada using the SBR ke, squirn bench reactor and so on lah. Ada many type of the biological treatment. Okay, and lastly is the clarifier. Clarifier, the concept ni sama lah. The concept similar with the water treatment. So we need to remove off the colloid or particle and then release the clear water. Okay, so radical to degrade all the organic lah. Okay, and clarifier to remove sludge or colloid particle. Okay, and the treated effluent must be comply with the standard. Okay, so in generally we have the three treatment commonly, but in our topic just cover until the second treatment. So this is the we call as the primary treatment, secondary treatment, success. Sometimes the treatment they have the tertiary treatment. Tertiary treatment commonly in the industrial wastewater. Okay, they required for the tertiary treatment, membrane and so on lah boleh guna. Okay, so this treatment ni we can discuss detail after this. Okay, return back activity ni activity sludge di supply balik lah back to here untuk degrade balik organic. Okay, semua yang mana sisa all the waste, solid waste here will be disposal to the disposal area ataupun storage. Okay, so this is Indah Water Consultant punya treatment plan bonus. Okay, sewerage and sludge treatment di location. So before that we look for the video in the pantai video. Okay,
development over it has brought many challenges in environmental conservation, especially in water pollution. However, the Malaysian government is very concerned and has been proactively seeking the best
ini adalah treatment plan untuk pantai dua sewage treatment plan. Dia berubah daripada typical treatment. So previously dia guna aeration punya method. They use the aeration aja. Only aeration to treat the wastewater. So this one dia guna aeration method. Okay, 26 tahun lepas dia guna irrigation method. And then the changing this method, okay, method kepada yang lebih terkini lah, advance lah. Okay, tapi advance pun still typical lah, typical. So this one irrigation lah, irrigation punya, okay, ni irrigation punya kaedah method. Irrigation ni cheap, but they require the largest area, okay, kawasan yang besar untuk for the irrigation punya pond, okay, irrigation pond. So the change from the irrigation pond kepada more sophisticated treatment plant. So the chain, okay, saya dah share video ni dalam author, so you boleh tengok lah the chain So the area can be used for the others purpose lah, because in the below area they provide for the treatment punya treatment plant punya facilities. Okay, so this is the basic lah. Inlet, they have the screen similar so they have the preliminary treatment. So this one preliminary treatment, and then after this is the secondary treatment. Okay, after clarify secondary treatment. So this one tertier UV channel Kalau common punya method dia tak akan pakai UV. Okay, bioreactor pun depend lah what the type. This one dia pakai AAO bioreactor. Okay, so kalau dalam typical dia guna SBR lah, sequence bench reactor, okay, anaerobic slash reactor, okay. So but this one dia guna AAO bioreactor. Okay, selalunya kita akan stop sampai here. Okay, after clarify we release the water to the water bodies. But in this system they have the UV channel UV channel tu disinfection punya proses lah. Okay, so and then barulah dia release to the outlet. Okay, so they have the second treat, okay, ataupun tertier treatment here. They use the membrane module and then untuk reclaim water. So after treatment by membrane, the water is in after membrane is the treatment that can remove small particle until the nanoparticles, is it? Okay, so by using the membrane module, okay, membrane treatment, so the water can be as the fresh water, okay. They can remove all the pollutant from the water. So usually this water can be used as a domestic water lah, tapi kita ours not confident to use this water, so we release to for the activities lah. Sometimes they release to the lake water and so on lah for recreational activity. Okay, this one slash lah, treatment slash here. So slash thickening, all this we learn lah. Okay, and then they generate the biogas here. So biogas ni can be supplied for the electricity. So this one kita akan discuss lah after this. Okay, this is the one of the treatment plant modern lah, more modern lah in the Malaysia. Okay, kalau if we have the physical class, so maybe we can arrange visiting to this treatment plant. Okay, so quite new and good lah for you to learn about the treatment plant process in the Pantai 2 treatment plant process. Okay, so this one sama macam tadi, hanya they have the certain part. Okay, ada primary treatment. Sometimes this one kita combine, kita cakap sebagai primary treatment lah. Okay, sometimes dia cakap call this one as the primary treatment, and then secondary treatment. This one depend lah, macam tadi you tengok in STP they have the UV disinfection. Okay, sometimes they have the extra for the tertiary treatment. Okay, this is the effluent discharge standard. So in the Malaysia we have the standard A and standard B. We have the standard A and standard B. So which area is comply with standard A, and which area comply with standard A, and which area is comply for the standard B. Here as the state, okay, standard A applicable to discharge into any inland water with the catchment area. Okay, and while standard B applicable to any inland water of the Malaysian water. So kalau A ni must be comply with the standard A if the water, okay, discharge into the catchment area. Catchment area, that means any area we have the water treatment plant. Okay, they have the water treatment plant before the discharging area. Okay, so in this figure, so let's say they have the industrial plant. Okay, this one the upstream, this one downstream. Okay, they have the discharge. Okay, they have the industry here. So here are the water treatment plant, WTP here. They have the water TP. So for the industry or any activities in the upstream before the treatment plant, so they required to comply with the standard A. Okay, so if the area after the treatment plant, so they need to comply with the standard B. So you should know lah, which standard should be comply with the effluent. Okay, ni mengalir upstream, so dia go downstream. So yang kawasan atas daripada sini, semua all the area activity upper here, okay, upstream from the wastewater treatment plant, from the water treatment plant untuk drinking water, untuk intake water. So here I have the pumping, they will take, and then for here all industry all need to comply with the standard A. And after this one, tak ada no water intake here, so it's okay, just need to comply with the standard B. But if they can be comply with standard A, is have the advantage lah, one of the good effort done by all the industrial. So similar what happened in your assignment 1, I give you for assignment 1, STP, okay, no STP, water treatment plant need to shut down because of the pollution. So the issue is the odor. So some compound released to the water, so they have the some odor. So this order higher, okay, the order higher from the standard. So that's why the treatment plant required need to the stop the operational or shut down the operational because the level of the order higher than standard. Okay, this is what happened in the Selangor lah. In the Semuanya treatment plant, Batu treatment plant, water treatment plant, they need to stop the operation because of the pollution, odor pollution more excessive than the standard. Okay, so the standard that is important all the industrial to comply with the Malaysian effluent standard. Okay, so this one adalah industrial okay, untuk 15, this one adalah industrial effluent. So they need required here. Yang tadi ni sewerage. Okay, sewerage, this one selalu STP lah, treatment plant. Ini treatment plant, this one for the industrial effluent. Okay, kalau treatment plant commonly they treat for the domestic wastewater. Okay, so we complete what is the pollution, the condition of the wastewater, what is the standard that they need to comply. Okay, so here we proceed for the hydraulic load. Okay, peak flow. So this is important before you design for the treatment plant. So you need to know what is the peak flow factor. Okay, peak flow factor. So this is the formula 4.7 multiply P power of negative 0.11. So P, what is the P? P is the equivalent population atau PE lah, population equivalent lah, PE. Okay, sometimes commonly lah we use in the PE. So the unit must be in the thousand, in the thousand. Kalau 20,000, 2,000, so you just masukkan 2,000 lah. Kalau dia dalam contoh 500, so dia akan jadi 0.5, 0.5. Okay, there must be unit in the thousand. Okay, this is the population equivalent PE. Okay, how many PE? So commonly this is just for the forecasting lah, forecasting estimation. What is the numbers people in the certain area? Let's say for the residential, okay, terrace house ke apartment ke so on. So 5 PE per unit. So jika residential have the 250 houses, so 250 houses you need to multiply with the 5 lah. So you akan dapat 1250 lah PE. Okay, so commercial depend on the area. So on this one 100 meter square. So kalau dia boot area 1000 you divide by 100 multiply dengan 3, so dia dapat lah berapa? So 1000 by 3, so dapat 3000 lah, 3000 PE. This is the way how you compute for the commercial area. So school, day fully residential, partial residential. So this is the equivalent. Kalau school day masuk pagi petang, sekolah pagi petang lah. Kalau they have the 500 pupils, so you multiply dengan 1. Okay. This one fully 0.2, partial 1 lah. Okay, so hospital depend on the bed. Dia bukan area, the bed. So if the hospital, this hospital, bed of the hospital 200, so 284, dia 800 PE. Okay, so hotel per room, factories per staff, okay, market per stall, petrol kiosk station per bay, per bay. So berapa tempat isi minyak tu ada berapa, how many bay. Okay, kalau ada sick bay, so kali dengan 18 lah. Okay, bus terminal per bus bay lah. Okay, berapa, sebab bus tu ada banyak, bus bay ni ada 20 kali 4 lah. So dia akan dapat 80. Okay, one peak flow is the equivalent 2 to 5 liter per capita. 225 liter per capita. 5 per capita. This is the peak flow lah, Q. Okay. So continue similar so you just read lah to understand how to determine for the PE, population equivalent. Okay, this example, calculate the peak flow for the new development area consists of the 250 unit 250. You tengok residential residential terrace house ke apartment ke, so houses multiply dengan 5, so the 125 PE. Okay, this is the peak flow dia tadi 2 to 5 liter per capita per day. So you multiply, so you akan dapat liter per day. So change unit 1000 liter 1000 liter equal to 1 meter cube. Jangan salah so dia bagi 1000, lepas tu kali dengan day bawah, day here. So one day have the 24 hours. One day have the 24 hours, 60 minutes, 60 seconds. So you kena multiply 281250, you divide by 100, multiply here. So you akan dapat 0.0 meter cube per second. Okay, so to determine the peak flow, this is the formula. 4.7 P in the 1000 so bagi 1000 lah. Bagi 1000. Tadi kalau 500 you bagi 1000 jadi 0.5 lah. Kalau 20,000 you bagi 1000 jadi 20. Okay, so divide by 100. Okay, power of 0.9 and then you multiply dengan hydraulic flow. So dapatlah peak flow. Okay, this one peak flow hati-hati peak flow. Peak flow must be multiplied with the hydraulic flow. Okay, kalau peak factor here, peak factor, so dia tak perlu. So kalau peak flow ni, peak flow factor. Okay, be careful this one for factor. Kalau peak flow that mean factor multiply dengan hydraulic flow, barulah you dapat peak flow. Peak flow saja. This one peak flow factor. Kalau peak flow you need to multiply with the hydraulic flow, barulah you dapat peak flow. Okay, kena be careful be careful between the peak flow dengan peak factor dengan peak flow. Senang cerita kita split dua lah. So kalau peak flow, peak factor equal 4.7 P power of negative 0.11. P must be in 1000. So letak je lah tu 1000 C. Okay, bahagi dengan 1000 kuasa 2. So for the flow dia dapat answer A. So for the flow A multiply dengan hydraulic flow. Hydraulic flow ni, how to get hydraulic flow? PE multiply dengan 225. Okay, this one you dapat hydraulic flow. 225 liter day per capita. So you must be change lah liter dengan day. Liter 1000 liter sama dengan 1 meter cube. Okay, day bawah, so day atas lah. Day bersamaan dengan 24 hours, 60 minutes, 16. So you need to multiply here lah to get the hydraulic flow in the meter cube per second. Okay, so this is the way how you can determine for the peak flow. Okay, must be careful lah, caution between factor and peak flow. So you need to read the question properly. Okay, either the question ask for the peak flow atau peak factor. So you could need to understand lah. Okay, so you try this one. So here based on the Malaysian standard 1225 NTY, the process design new domestic wastewater plant should be basis of the 51 gram of BOD per capital to the 88. So between this range lah, 55 to the 88 gram for BOD capital per day. Okay, so we proceed for the process. We know we done already to compute for the peak flow. Okay, hydraulic flow, PE multiply with the standard capita, flow per capita, 2 to 5 liter per day per capita. Okay, and then you get the answer must be changed in the meter cube per second, and then you need to multiply with the peak flow. Peak flow is the 4.7 PE equivalent in the 1000. PE tu you need to divide by 100, power of the negative 0.11. Okay, this is the way how you can determine for the peak flow. Peak flow tu the height of the flow that enters to the treatment plant. So when the wastewater enter to the treatment plant, so firstly we need to the preliminary treatment. Okay, preliminary treatment. So by using the bar racks and screen, okay, to remove the large float material, so protect downstream mechanical equipment, okay, such as the pump and so on lah, the machine ataupun dia punya rotary screen. Is the mechanical or manual clean solid material stored in the hopper and sent to the landfill lah. Hopper tu yang ni lah, angkat tu, lori angkat lah. Okay, so dia boleh bersih secara manual. This one as the manual, this one as the automatically. Okay, grid is the organic. Similar dalam water treatment, you already learn how to design for the grid chamber. Similar, sama. Okay, this is the inorganic sand and gravel particle of the size about the 1 mm, which are washed into the sewer collection. Okay, system from the roads and the pavement. Okay, grid should be removed because it is inclusion with the system can abandon mechanical equipment. Okay, sebelum dia rosakkan mechanical lah. So that's why it's important to remove the grid before enter to the wastewater treatment plant. Okay, also because can be settled out in the biological treatment. The settle out the treatment reduce the space efficiency. So let's say for the biological treatment we have the 100%, so dia akan sediment here, so the capacity will be reduced. Okay, the grid here. So that's why we need to remove earlier in the preliminary treatment. Okay, normally the type 1 sediment is applied to remove grid. Okay, they using the type 1 sediment. The type 1 sediment using the yang VS tu lah, stop formula. G density particle minus density water divide by 18 new. Tak silap saya lah, nanti cemak balik betul kat betul. Diameter saya lah, diameter. This one diameter particle, density suspended ataupun particle, this one density water. Okay, specific gravity, this one specific gravity equal density substance water. Okay, this one PS ni for the density of the substance ataupun particle lah. So you can change here. So density depend SG, density water usually 100 lah. So this one depend on the temperature lah, Okay, density depend on the temperature. Okay, for the grid chamber using the Malaysian standard, okay, 3 types of the grid mover system comprising either the horizontal constant grid chamber, errated grid chamber or deteriorator. Okay, the horizontal flow grid chamber, this is the standard. The velocity should not exceed 0.3 meter per second. Okay, surface loading rate should not exceed 1500 meter cube per day per meter square. This one kalau you simplify dia sebenarnya meter per second. This one kalau you simplify here meter per day jadi meter per day. So you need to change meter per second lah. Okay, so velocity flow dia VH lah, yang flow ke sana, bukan VS Yang VS tu particle punya velocity. VS ni you can determine using this formula. Okay, so you need to different between particle dengan tank punya velocity. Okay, rated gauge chamber maximum detention time 3 minutes. Okay, air rate should be the range 4.5 to 12 liters second per meter of the tank. Depth to wave 1 to W lah. Okay, Kalau depth width ni kalau area sini. Okay, depth width. Okay, so that's mean area yang ni bersamaan dengan 2W multiply dengan W, so dia 2W kuasa 2. Okay, so for this requirement. Okay, length depth ratio ni. Okay, D dengan L sini. Okay, kalau kita apply commonly type 1 type 1 saya dah explain tadi using the step law. Okay, this is the example. Design the rectangular tengok soalan satu buah aja you design for the single horizontal grid remove velocity to remove the grid and the specific gravity of the 2.6. okay, SG equal 2.65 and particle velocity range, okay, ni VS lah, VS particle dia 0.016 to 0.022 meter second. Okay, ni horizontal meter per second, di loading lah. Loading, determine the channel for the maximum flow. So this one the Q. Ni V. Okay, VQ. So you daripada sini you can determine the depth, okay, settling velocity VS. So between ni you ambil paling minimum lah. Okay, detention time dah cakap must be 6 second. Okay, so TD sama dengan depth divide by velocity settling. Ni VS depth mesti divide by VS bukannya 0.3, 0 particle. So TD you get 0.6, so you need to plus 0.3 per freeboard. Let's say this one your punya grid chamber. So the freeboard here mesti ada free. Kalau air dia penuh, so this area still have the free area. Okay, emergency ke apa, so jika ada tersumbat ke apa, so dia have emergency 0.3 meter. Okay, so 2.5 you can accumulate design dia here A, so you can tambah di bawah lah untuk dia accumulate. So dia punya capacity still same. Kalau apa-apa the grid still accumulate here, so the capacity still remain the 100% lah. So that's why you need to plus 0.25. So the depth is the 1.5 meter. So 30 second ni kita assume usually until 3 minutes. Okay, until 3 minutes, 1 to 3 minutes lah for the detention time. Dia tak lama-lama. Okay, so the length TD horizontal length TD detention time kita tahu. Okay, so length here sama dengan TD bagi dengan VH flow nya sini, flow yang datang sini VH is 0.3 ataupun loading 0.3 meter per second. TD this one we assume tadi between saliness 1 to 3 minutes lah, 1 to 3 minutes. So multiply, so you get 8 meter. So 55% for the inlet and outlet zone. So you multiply dengan tambahan 25% 1.25 je lah. Design dia 100%, this one 100%. So you tambah 25%, dia 1 to 5% lah, 1 to 5%. So you multiply dengan 1.2 lah. So the length ada 2 to 2.5 meter. Okay, so A sama dengan Q dah VH. Okay, so A bersamaan dengan Q darab dengan VH. Okay, this one cross section. So Q 0.3, so A 0.3, so dapat meter square. So depth already know, so you can get the width the 1.26 meter. So settle. So gate chamber ni beza dengan sediment sedimentation tank. So gate chamber ni dia yang area ni, cost area. This one here, cost area here. So bila Q, okay, V darab dengan A. Okay, try to design for this one. Yang ni dia tak ada mention tak ada mention this one primary sediment ni soalan primary sediment tank sorry ni exercise tu ni sediment tank yang kita buat tadi grid lain sediment tank nanti kita akan Okay, so this one is the preliminary treatment, equalization. Sediment tank ni selalu kat ujung. Okay, this one soalannya kat ujung ni. After biological treatment. Biological treatment barulah ada sediment tank. This one sediment tank ni. Soalannya sediment tank lain bukannya grid lain. Grid chamber lain. So this one kat ujung nanti, soalan ujung. Okay, we proceed this later. So for the preliminary treatment, is the equalization tanks. Okay, part of the after we complete for the grid removal, we conduct the next process is the equalization tank. So the wastewater produced often varies in the overall water flow. Okay, as a result of the day and night production process. So they tak sama, they fluctuate. Okay, the new flow is the fluctuate. They're not consistent. So water enter to the wastewater treatment plant is the varies. Okay, fluctuate, naik turun. They have the naik turun. Okay, as the concentration of the pollutant being different at the different time, different pollution. So they have the different capacity, quantity. Okay, so that is the purpose of the equalization tank. So we need to equalkan equalization, samakan. Okay, setarakan. Okay, equalization the tank. This is the objective. The first, flow to minimize flow charge. Okay, tak ada lebihan, tak ada kurang. Equalization the organic loading to depend the fluctuate. Okay, so dia nak setarakan for the organic. Okay, tak dia naik turun kejap. BOD, sometimes BOD 200, sometimes BOD 100, sometimes BOD 500. Okay, so we need to equalization for the organic. Utilize the pH version to bring the range 8.5 and 6.5 to the 8.5. Okay, ni similar lah pH organic to provide in continuous influence to the plant. So tak adalah sometimes the plant they not have the sufficient volume to run for the treatment plant. So by produce ataupun provide the equalization, so we can control the influence of the plant. Okay, so we also can control the high toxicity load, equalize the flow rate to balance the nutrient and to balance the pH. Okay, this is the example to calculate for the equalization tank. So this one tengok 24 ni, period ni hours 24 hours. Okay, 24 hours to 1. Okay, so 1 hours ni 1 hour, 1 to 2, 1 hours. So 3, 4, 5. So all this one have the 1 hours 1 hours. So average flow rate for the each hours is so yang masuk berapa in the equalization tank. Okay, 2 to 5 liter per second until 24. See ni first hour 1, 2, 3, 4, 6, 7, 8, 9. So 12. This one 12 hours. So this one for in a day. So each hours they have the flow. So now flow dia berbeza-beza the different flow. So ada naik sejak 25, sejak 400 naik turun depend on activities so human activities. So how we can design in the storage volume. Okay, how we can design in line storage volume. So the tank for the equalization, how we want to design, berapa besar, how bigger for the equalization to make sure the volume that required for the treatment, we have the sufficient volume for the influence into the treatment wastewater treatment plant. Okay, this is this time period. So for all these 1 hours, so influence how to get this one in a meter cube. So this one given the liter per second. Okay, 275 liter per second. Okay, so this one dalam 1 hours. So we have the 1 hours. So 1 hours you need to change in the second. Okay, so you second and then you kena multiply liter, 1000 liter equal 1 meter cube. Okay, this is the way how you can determine for the influence. Okay, so you complete for the table 1 first column 2. So column 2 ni bukan ni from here 275 you multiply with the how many second in the 1 hour. Okay, 1 hour ada berapa second? 1 hour ada 60 16 second. Okay, so 225 you multiply dengan 16, 275 you multiply dengan 16. 1 hour ke 1 day? 1 hours is it? Yeah, 1 hours. Okay, 1 hours. 16 minutes, 16 second 16 minutes, 16 second. 16 minutes, 16 second. So 275 multiply 60 multiply 60 divide by 100. 100, so you dapat 990. So you kena complete here dulu lah. 990. Ni 225 yang sini. 25 kali 1 hours. 1 hours sama dengan 60 kali 60 kali 1000 liter equal 1 meter cube. So hours settle lah. Okay, second, settle second. 1 liter per second second, liter second, settle second. So liter second, so yang tinggal adalah meter cube. This the way lah. Okay, you complete sampai bawah. Complete column 1. Selesaikan sampai bawah, and then you get this answer. Okay, this answer you need to divide effluent. Effluent ni how to get this answer you divide. So sini ada berapa jam? How many hours here? They have the 24. So this one sum here. You dah tambah ni, tambah, sum all this, and then you get 26,532 meter cube. So you need to equalize. Nak keluarkan dia dengan sama kan? So you need to equalize. So this one you divide by, here ada berapa jam? 24. So you divide by 24. So 26,532 divide by 24. So dapat 1,105.5 meter cube. Okay, this one you divide lah. This one you divide. The answer ni contoh saya kata tak A lah. So A you divide by total hours. Okay, total hours. Total hours 24. Kalau total hours the design for 12 hours, so divide by 12 lah. Kalau the design for the 48 hours, so you need to divide by 48 hours. Ni nak setarakan you need to equalize kan, samakan. So total you equalize kan. Bila dah sama, semua ni adalah samalah, equal to 110. You letak 110 semua here. Okay, settle Lepas tu barulah you anjak tu kolom 3, kolom 4. Okay, for the kolom 4, this one cumulative. Okay, cumulative maksudnya for first hours you plus dengan this one, atas dia kosong kan, kosong tambah here 990. Okay, lepas tu 990 ni you plus 765, so you get 1,785.6. Lepas tu this one you tambah dengan, okay, you tambah ni you get here. So here you tambah dengan ni you get here, this one plus, settle lah, tambah dapat, tambah dapat, tambah dapat, tambah dapat, sampailah ujung. Bila last kali 2025 ni you tambah dengan 1000 ni, mesti dapat samalah, kumulatif lah, sama dengan here, sama dengan here. Okay, when you dah get the same answer, similar to effluent yang here pula, here first tambah atas kosong. Okay, and then you tambah here, dapat here. So kalau yang effluent ni multiply lah, 110 multiply 1, this one multiply 2, 3, 4, 5, 6, 7 sampai multiply 24. This one sebab dia sama. Okay, ataupun you buat tambah, plus, and then you make sure have the same volume. Okay, so masuk sama, keluar sama, mass balance kan, equalization, imbangkan. Okay, inlet outlet sama. Okay, and then barulah you different, beza kolom 4 tolak kolom 4 tolak kolom 5. Okay, kolom 4 tolak kolom 5. Okay, negative value ni that's mean dalam bila dia dah release, that's, so dia ada baki lah, ada baki. Okay, dalam tank tu maksudnya kosong, bukan kosong, dia ada space. Okay, negatif. Kalau nilai dia plus, maksudnya in the tank bila dia release, contoh let's say the example, they release the water, so if the negative that mean in the balance tank no water in this balance tank. If the answer positive, that mean here still remain the water here, still have the water, wastewater here. If negative, okay, sebab because all the go as the effluent. Okay, so positive, negative, this is the meaning. What is the meaning of the negative? That mean the balance, no water in the balancing tank ataupun equalization tank. If the completely different have the positive value, that means the water in the balance, they still have the water in the balancing tank. Okay, this is the meaning of the positive and negative. Okay, so effluent, so negative. So you dah complete all this one, and then barulah you proceed to design for the settle settle. Saya dah explain tadi, settle. Semua settle. Okay, then saya explain tadi negatif maksudnya all tak ada in the tank, in the balance, no water in the balancing tank. If negative, kalau positif they have the, so tak ada masalah. Positif negatif tu tak ada masalah. Just sign of the water inside of the tank, or the water have the in the balancing tank or not in the balancing tank. That's all. That's the meaning of the positive negative. And then lastly, this one smallest negative difference plus largest positive difference. Okay, smallest negative. This one, be careful smallest negative different smaller negative. So smallest tu yang besar tu lah, smallest. Okay, nilai yang you tengok ni. The easy way, you need to look the numbers sajalah. You look the numbers, mana paling besar. You jangan keliru dengan ni lah. Jangan keliru dengan this term. This term ni memang betul ayat dia gitu. Absolute value of the smaller negative, smallest. Negative 1 and negative 100, which one is smallest? Negative 100 lah. Betul tak? Okay. So to avoid from you confused for this value, sometimes student they think 100 is the largest because 100 and 101 they not look at the negative. Okay. So the best way, you just find the negative and positive sign, which one have the negative and positive, you don't look, just find the largest numbers. Okay, contoh here largest number is 42. Okay, 4110 largest number. Let's say example here, and another here sini tak ada negatif, ada positif. Okay, ini tak ada negatif, contoh so largest for negative here, largest for the positive here. So you need to plus 2 ni. Okay, kalau all the negative tak ada positif, so okay lah, no positive here. So if no positive, okay, none lah. Okay, so you just look at the largest numbers for the negative side and the positive side, and then you get the both two, you plus, and then you get this the volume for the equalization tank. Okay, boleh faham tak? Should be boleh faham lah. Okay, ini hati-hati then just nak tengok volume, numbers mana paling besar untuk negative sign dengan positive sign. That numbers ni, contoh AB ni, numbers for the negative sign 4000, number for the positive, so you tambah, so you can get the volume for the equalization tank. Okay, and then extra 100%. Okay, for the safety factor, so 5413 meters cube. So this one you assume, this one tak ada ni equalization, tak ada no standard ataupun guideline, dia just one tank, so they depend on the area lah. Kalau equalization in the rectangular, so usually we can use L sama dengan 2W lah. Okay, we assume this one lah for the rectangular. Okay, so when you complete for the L and width, and then you can get height. Okay, so this is the equalization tank in the dimension, length dimension lah. Okay, for the rectangular dimension, kalau circle pi d lah, pi d kuasa 2 for area. So you get the D, and then you get the H, depend lah the equalization tank, type of the equalization tank, either in the rectangular or circular. Okay, I stop until here. So we will continue for the chapter 3.6 for the next meeting. Okay, thank you all.